Hello students, welcome to mathematics class. Students, this is part 1 of the chapter number 11, Algebra. In this part 1, we will learn introduction to algebra, and later we will learn some of the important terminologies related to this chapter, algebra. Now coming to the algebra chapter, in class 6, what going to be emphasized would be first introduction. Let me take introduction first here. Children, our study so far has been with the numbers and shapes. We have learned numbers and their operations on numbers and properties of numbers. We applied our knowledge of numbers to various problems in our life. The branch of mathematics in which we studied numbers is arithmetic. We also learnt about figures in 2 dimensions as well as in 3 dimensions. And later we learnt the properties of them. The branch of mathematics in which we studied shapes is called geometry. Now we begin the study of another branch of mathematics, very important branch of mathematics called algebra. Children, the main feature of the new branch which we are going to study is the use of letters. Use of letters, we can talk about any number and not just a particular number. Use of letters will allow us to write rules and formulae in general way. What does this letters means? Letters may stand for unknown quantities. Very important, they stand for unknown quantities. By learning methods of determining unknowns, we develop powerful tools for solving puzzles, many problems from the daily life. And thirdly, since letters stand for numbers, operations can be performed on them as just like numbers only. And this leads us the study of algebraic expressions, very important, algebraic expressions and their properties. So you will find algebra interesting and useful. It is very useful in solving, very importantly children, when you will be solving some of the word problems, you will be using this. Now let us begin simple examples. And the important things that you are going to learn in this chapter: first, matchstick patterns. Next, you will be learning the idea of a variable, and then use of variables in common rules. Then in that, rules from geometry, rules from arithmetic, and children, expressions with variables and mathematical expressions and arithmetical expressions, and you will be learning the important concept called algebraic expressions. These are the important topics that you are going to learn in this chapter. Now coming to the matchstick patterns. Children, here I have taken 2 matchsticks and arranged them like a L. You could see that L shape. Now I am going to take 2 more matchsticks, arrange like this, 2 L's. Total I have used 4 matchsticks to form 2 L's. Further, I will take 2 more and I am going to arrange as 3 L's. Here totally number of matchsticks that I used for making 3 L's is 6 in number. Now if I do it further so on like this, so many number of L's. If I wanted to know how many matchsticks should I be requiring to form 6 L's? This is the question. Children, if we want to answer how many L's that can be formed out of given number of matchsticks, or if you wanted to say how many matchsticks required to form this many L's, you need to compulsory go for some logic behind that. Let us see number of L's formed for 1 L and number of matchsticks required 2. For 2 L's we required 4. For 3 L's we required 6. Similarly, if I wanted to form 4 L's, I require 4, say 8 matchsticks. If I want to form 5 L's, I require 10 matchsticks. If I do this so on for 6 L's, I require 12 matchsticks. If I do this so on, children, for the sake of n number of L's, I require twice of them. You could see that logic here by seeing the pattern. For 1, 2, for 2, 4, for 3, 6, for 4, 8, for 5, 10, for 6, 12. So for n, it would be 2 into that n, 2 times n. So this is the logic which we have used. Now you try to observe number of matchsticks required. I made as a formula or a generalization using the letter n. This n says that unknown number. So forming generalizations can be done with the help of these unknown numbers, and for that unknown numbers I am using letters. Children, let us do some more work on the matchstick patterns. Watch, I took 3 matchsticks and formed a shape C, and I took 3 more matchsticks and formed the shape C's for twice. You could see that pattern. And I took 3 more. With a total 9 number of matchsticks, I formed 3 C's, and for 4 C's I require totally 12 matchsticks. If you want, you can count them, and further, if I am asked how many matchsticks will be required to form 6 number of C's. Children, here again the formula would be 3n, that you can ensure by taking the table. For 1 C sec 3, for 2 C sec 6, for 3 C sec 9 matchsticks. You can count and check if you want 1, 2, 3, 4, 5, 6, 7, 8, 9. So for 4 matchsticks sake, for 4 C sec 12 matchsticks, and for 5 sec 15, for 6 sec 18 are required. That is the answer here. And if you want, for n number of C's, you require 3 times of them. This 3n gives you generalization which I formed with the help of unknown number or letter n. Children, little further, you could see here forming F. In this F, how many matchsticks are used? For 1 sec, 1, 2, 3, 4. So 4 are used. For 2 F's, 1, 2, 3, 4, 5, 6, 7, 8. 8 are used. Now you are getting the idea how many would be used here. Obviously 12. You can cross check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Children, here if the question is asked, can you now write the rules for making patterns of F? Obviously, yes. What is that? It is a 4n. Number of matchsticks required will be 4n. That you can cross check by seeing this table. For 1 we require 4, for 2 F's we require 8, for 3 F's we require 12, for 4 sec 16, and for 5 sec 20 and so on. For n number of f's, if you want to form, you require 4 times of that n matchsticks. So I formed again generalization. Children, very important here, think of other letters. Is it compulsory that I must use n only? No. Think of other letters of the alphabet and other shapes that can be made from the matchsticks. For example, letter U, letter V, letter triangles, let's say 3 matchsticks are used. For the sake of square, 4 matchsticks. Choose any 5 of this and write the rules for making matchsticks pattern with them. And now the question comes, we have used the letter n to show a variable. Why not m? Can we use? Obviously we can use. There is nothing special about n. Any letter can be used. Children, here important thing, what is this? M, L, X. One may use any letter as M or L or P or X or Y or Z, etc. to show a variable. Children, very important, the word variable. It is also called literal. Children, what is the meaning of variable or literal? So, in algebra, letter representing some unknown number is called variable. Or it is called literal. In general, the word variable tells the thing which can be vary, the thing which can vary. The one which can vary means change. So the thing which can keep changing or can change. So here the value of a letter can be any number. So it can be keep changing. So that's how this variable word has come. Letter representing numeral. Putting together literal, this word has come. Letter representing numeral is literal. So remember, a variable is a number which does not have a fixed value. It will never have a fixed value. For example, the number 5 or the number 100 or any given number is not a variable because it has a fixed value. They have very fixed values. Similarly, the number of angles of a triangle has a fixed value, that is 3. It is not a variable. The number of corners of a quadrilateral, 4, is a fixed number. It is also not a variable. But n, in the examples that we looked, we have already learned, they are all variables because they can change. It takes various values from 1, 2, 3, 4, anyone. So that's why that letter is a variable. Children, now let's go for the idea of a variable. The word variable means something that can vary, nothing but change. So the value of a variable is not fixed. It can take different values. N is an example of a variable. Its value is not fixed. It can take any value, 1, 2, 3, 4, anything. We wrote the rules for the number of matchsticks required using the variable n. Now, let us now consider variable in a more familiar situation. Suppose students went to buy notebooks from the school bookstore. Price of one notebook is rupees 5. Munnu wants to buy 5 notebooks. Appu wants to buy 7 notebooks. Sara wants to buy 4 notebooks, and so on. How many or how much money should a student carry when she or he goes to a bookstore or to buy the notebooks? What would be the number of books that if they wanted to buy, if they know that, and how much money that they are supposed to carry? This is what to be calculated. Children, it is very simple that this will depend on how many notebooks the student wants to buy, and the student work together to prepare a table, number of notebooks required and the cost. Suppose if I want to buy 5 notebooks, I need to carry the total cost, because one notebook 5 rupees and 5 becomes 5 5s 25 rupees. And suppose Appu wants to buy 7 and is supposed to carry rupees 35. How this 35 has come? It is just number of notebooks into cost of one notebook 5 gives the cost of total number of books. Suppose that Sara wants to buy 4 notebooks, that means she is supposed to carry rupees 20, as 4 into rupees 5 gives rupees 20. Suppose you want to buy m number of notebooks, then what is the money that you have to carry? It is obviously m into 5, or it is written as 5m. Okay, rupees 5m or m into 5, that way we can write. Children, here one more example I would like to give you. Here Raju and Balu are brothers. Balu is younger than Raju by 3 years. Balu is younger than Raju by 3 years. When Raju is 12 years old, Balu is 9 years old, obviously. When Raju is 15 years old, Balu is 12 years old. We do not know Raju's age exactly. It may have any value. Let x denote Raju's age. Let x denote Raju's age. If Raju is of x years, then what would be the Balu's age? This is the question. So, children, Balu's age, you need to tell in terms of Raju's age, would be, see, Balu is younger than Raju by 3 years. That means whatever is the age of Raju, from that I will subtract 3. Isn't it? So, x minus 3 years. This is how we do make use of the variables. If Raju's age in years is x, then Balu's age in years is x minus 3. The expression x minus 3 is read x minus 3, and as you would expect, when x is 12, then x minus 3 is 9. When x is 15, then x minus 3 is 12. Children, this is the idea of variable. Children, with this I will wind up this session. In our next class, I will carry further very important matchstick pattern things further, and we will solve exercise questions of 11.1. So, till then, take care of yourself, be healthy and be happy. Jai Hind. Thank you.